All right, so exam two, it's done, it's graded. You have your grades. Some of you did really well, and that's awesome. You might not even be watching this if you're one of the people that did really well. If you didn't do well, I'm going to walk through all of the questions on the exam, but just like last time, there were two versions of each question. I'm going to walk through both versions. So, like you're welcome to watch both if you want to, but it also, it's not going to hurt my feelings if you skip to the one that was yours. And also, I won't know. So that's, you know, it's whatever. It's up to you. Okay, let's do this. Let's do this. Let's do this math. First thing that we want to do is let's take a look at the question. So you're going to compute the percent jitter, and then the next thing you're going to do is compute the percent shimmer. You know what? I'm looking at this in the wrong way because this is only showing me one version. There we go. So there's two versions of this question. One has 0.83, 0.65, 0.85 along the top. The other is 0.74, 0.55, and 0.76. It was randomized which one you'd get. So sometimes you got the same one for both. Sometimes it switched on you. But we're going to do jitter first. Jitter is the frequency down here. So I guess the first one I've got set up is 0.08, 0.081, and 0.09. So we're going to come over here, and one of the first things that you want to do is, like, it doesn't really matter which one of these steps you do first. So I'm just going to do this first. But we're going to do 0.08, 0.081, 0.09, 0.072, 0.11, 0.072. I'm writing too big. 0.011. That's not what it is. 0.101, 0.06, and 0.065. The first thing that I'm going to do is I'm going to take the sum of all these. Again, like I said, at this point, the order of steps doesn't really matter. You could subtract each one from each successive number first and then take the sum of those. That's totally fine. It doesn't matter. As long as you know which one goes on the top and which one goes on the bottom, you're good. So let's write out our formula really quickly. So what we want, jitter, is going to equal every each one of these numbers minus the next number. That's this each number, and this is each successive number, n plus 1. So like n, you start with 1, n plus 1. If you started with 1, it's 2. So n minus n plus 1 is right here. That's going to be divided by n minus 1. And then we're going to divide all that by the sum of each frequency spacing over n. That's our formula. Shimmer is basically the same thing. You just replace the jitter with a shimmer, and you replace the what are we going to say here? Amplitude, I guess. That should be with each amplitude. Oh no. There we go. There. All right. There we go. So shimmer is going to be basically the same thing. You just use a different set of numbers. Use the amplitude numbers instead of the frequency numbers. So there's your formula. Okay, let's keep going. So what we're going to do, I'm starting with the denominator, which is going to be sum all of these and divide by n. N in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9. And n is going to equal 9 for all of these. Okay. So 0.08, that's the sound of my trusty calculator that you hear clacking around. 0.081 plus 0.09 plus 0.072 plus 0.11 plus 0.072 plus 0.101 plus 0.06 plus 0.065. That equals 0.731. And we're going to divide that by 9. I've already got that written here somewhere. 0.731 divided by 9 equals 0.0812222 repeating. So this number is one that we want to keep. That's going to be our denominator. I'm going to write it down here. 0.081222. And let's get rid of the rest of this. Okay. So now what we're going to do is we're going to subtract each one of these from the next one. And I don't mean 0.08 from 0.081 and then 0.08 from 0.09. I mean you're going to move through and subtract each group as you move through. So it's kind of like you're taking a two number window and you're just sliding that window around, basically. All right. So your numbers are going to be 0.001, 0.009, 0.018, 0.038, 0.038, 0.029, 0.041, and 0.005. Keep an eye on this one right here, double zeros. I didn't take any points off for this. Many people put it in as 0.05, including, not for this one, but for the other one. I also typed a 0.05 in as I typed in a 0.005 as 0.05 when I was making the key the first time. So if it's a mistake I can make by like butterfingering my calculator, I'm not going to count you off for it either. So what you're going to do now is you're going to take the sum of these numbers that you just calculated. Here's the thing though, there were 9 actual numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and now there's 1, 2, 3, 4, 5, 6, 7, 8. There's always going to be one less of these numbers because you're taking each group of 2 and subtracting them to get one number. So there's always going to be one less of these subtracted numbers. When you're finding the difference, there's always going to be one less than the actual numbers. So the sum of these differences is 0.179, and then you're going to do 1.179 divided by 8, and 0.179 divided by 8 is 0.022375. Yay. So now the last portion, we found the numerator, we found the denominator. What we want to do is divide the two. So, smaller number should always be on the top. 0.022375. You know what? That was a weird way to say that. Smaller number should not always be on the top. What I mean is, in this case, the smaller number is the one that we computed for the top. So, when you're dividing by n minus 1, that's the top. And when you're dividing by n, that's the bottom. It should work out in all of these that the top is a smaller number because it's a percentage, right? And a percentage shouldn't be smaller than 0, and it shouldn't be larger than 100%. It can't be. And so there you go. It's going to be between 0 and 100 every time. So if you compute this and you get 200%, or some people got 200%. I saw some people got like 1,000%. And then there was also a negative percent that somebody had. That's definitely wrong. That should be a cue that you got it wrong and you got to go back. Okay, so you have 0.022375, and you're dividing that by 0.081222, and that equals 0.2755, but you're going to multiply by 100 for a percentage, which is going to be 27.55%. Based on rounding, this is going to be anywhere between 27 and 28, something like that. And of course, you got full points. Anywhere between there, rounding is totally fine. All right, next. We are going to do the shimmer of that same image. So now we're computing shimmer equals, I'm going to write the formula up here in small form. It's the sum of amplitude n minus amplitude n minus 1 divided by n minus 1 divided by the sum of every amplitude over n. What are our amplitudes? They are 0.83, 0.65, 0.85, 0.82, 1, 0.79, 0.4, 0.35, and 0.3. Okay, so the first thing, again, that I'm going to do here is I'm actually going to do the denominator. It's faster since I have it up. The sum of all these numbers is 5.99. And then we need to divide that by n. So 5.99 divided by 9 equals 0.66555 repeating. So we're going to drop that down here and save it for later. And let's compute the top of our fraction. So to compute the top of our fraction, we're going to subtract this one from this one and keep doing that all the way across. The numbers that we end up with are 0.18, 0.2, 0.03, 0.18, 0.21, 0.39, 0.05, and 0.05. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. In this case, n minus 1 is 8. Should be 8 numbers here. What we're going to do is we're going to take the sum of all of these numbers, and that is 1.29. Then we're going to take 1.29 and divide that by 8. That equals 0.16125. Okay, one more step. Which is we're going to put our 0.16125 over 0.66555, which equals 0.2423, multiplied by 100 for a percentage, and we get 24.23%. Just like last time, rounding is going to have a huge effect here. Well, it's not a huge effect, but somewhere within, possibly 23 to 25% is an answer that I would accept. Okay, now I'm going to move to the other image. Same question 1 and 2, but the other image. All right, so we are doing jitter for the first image. The numbers that we get are 0.07, 0.072, 0.088, 0.065. That's a 6. It looks like a G with a swirl in it, I guess. 0.112, 0.065, 0.1, 0.05, and 0.055. First thing that I want to do here is just get the sum of all of these, and I have to do this in real time because I screwed it up on my key the first time, and then I wrote it in after I caught my error, but now I can't read. I wrote it right over it. I can't read it. So 0.07 plus 0.072 plus 0.088 plus 0.065 plus 0.112 plus 0.065 plus 0.1 plus 0.05 plus 0.055. Is 0.669. Is that right? Hang on a sec. I feel like I typed one of those in wrong. There we go. It's 0.677. What did I do wrong? I don't know. But that's what I had the first time. So 0.677. See, this is, you can so easily just kind of like type one of these in incorrectly. 0.06, but yeah, these all look right. It's easy to miss a zero or jump over a number. So 0.677. Our n here is 9. We're going to do 0.677 divided by 9, which equals 0.075 repeating. I'm going to write that down here to save it for later. 0.075 222. And now let's do our numerator really quickly. Okay. To find the numerator, we're going to subtract this number from this number and keep going through all of the rest. And what you should get is 0.002, 0.016, 0.023, 0.047, 0.047, 0.035, 0.05, and 0.005. Good. Add those together. 0.002 plus 0.016 plus 0.023 plus 0.047 plus 0.047 plus 0.035 plus 0.05 plus 0.005. Should give you 0.225. If you got 0.275, which is what I got the first time I made the key, it's because you forgot a zero right here, which I totally did. Okay, here n minus 1 is 8, so we're going to put 0.225 over 8, and that equals 0.028125. All right, we have one last step. Which is put 0.028125 over 0.075222. That equals 0.3739. Multiply by 100 to get a percentage, which is 37.39%. Rounding is going to have a huge impact here, so anything in the high 30s, you got full credit for that. Okay, let's move on to our last one, which is shimmer. All right. The numbers that we have for shimmer are 0.74, 0.55, 0.76, 0.73, 1, 0.68, 0.4, 0.35, and 0.3. Yeah, that's right. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. N in this case is 9. The first thing we're going to do is add all of these together, and that is it's 5.51. All right, and then what we're going to do to get the full denominator is we're going to divide 5.51 by 9, which gives us 0.61222, repeating. I'm going to drop that down here so we can save it for our next step. We're going to get rid of all this. So the next thing that we're going to do is subtract each of these from the next one. We're going to end up with 8 numbers, so n minus 1 equals 8. And the numbers that you should end up with are 0.19, 0.21, 0.03, 0.27, 0.32, 0.28, 0.05, and 0.05. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's right. Okay, so what you're going to want to do is add each of these together, which should give you 1.4. And then our next step is to take 1.4 divided by 8. How many there are, we're kind of finding the average here. And that should give you 0.175. So that's our numerator. We have our denominator down there. We got one last step. Which is 0.175 divided by 0.61222 equals 0.2855. Multiply that by 100 to find a percentage, which is 28. Oops, it's actually 0.2858, sorry. Multiply it by 100 to get a percentage, and it should be 28.58%. There's your answer. Just like last time, rounding, depending on where you rounded, it's going to have an effect. So anything in the high 20s is a number that I'll accept. Okay, let's get rid of all this and move to question 3. Question 3 is, let's drop it down. Nope, we did that. All right, question 3. Draw the output for the first 6 harmonics of a complex tone with a fundamental frequency of 90. And this one has a fundamental frequency of 105. So let's do the first part of this for each question. First 6 harmonics of a complex tone with 90 and a first 6 harmonics of a complex tone with 105. I'm going to draw a line down the middle. Here we're going to do 90 hertz, and here we're going to do 105. So the first 6 harmonics of 90 is basically you're just counting up by 9s and multiplying it by 10. So your first 6 harmonics are 90, 180, 270, 360, 450, 1, 2, 3, 4, 5, and 540. There you go. 105, your first 6 harmonics are 105, 210, 315, 420, 525, and 630. 1, 2, 3, 4, 5, 6. There you go. You want to draw those as a picture because that's what it wants you to do. You're just going to take these, make a little bar like this, a little really long L, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. And then you can just draw your little numbers in there. I'm not going to do them all. It'll take too long. 105 to 630. Okay. What do we need to do next? For you people who have 90, you need a high pass filter above 300 and a band pass between 1 and 4. Let's write that down. So it's a high pass above 300 hertz, and number 2 is band pass 1 to 400 hertz. What about 105s? You need a high pass above 500 and a band pass from 250 to 450. All right, we are gonna do 90 hertz first, and I'm gonna switch my color. Your high pass filter, 300 and above, it's only gonna permit things 300 hertz and above, which means it's gonna knock out 90, it's gonna knock out 180, it's gonna knock out 270. The last three it's gonna permit. And so what you can do is you can draw your filter like this. It lets those last three through. 105s. Look at your list of frequencies. What is above, like cross out whatever is below 500. 105, 210, 315, 420, they're all out. 525 and 630 are above 500 hertz. You can draw your frequency like this. Or your filter, like this. The last two frequencies are permitted. Okay, now let's do our band pass in a different color. Band pass, we need to figure out, we're going to 90 hertz people now. What is between 100 and 400? Well, 900 is not. 180 is, 270 is, 360 is, 450 is too high, 540 is too high. So you're going to knock out your first one and your last two. Your band pass filter is going to look like this. 105s. What is lower than 250? Well, 105 and 210. What's higher than 450? These last two. So you're permitting the middle two. Your band pass filter is going to look like this. Just permitting the middle two. There's the answer to question 3. All right, question 4. Question 4. What? Yes. There was a few problems with this one. So, what is the length of a tube with one end closed that can amplify 395 as either the first resonant frequency or the second resonant frequency? The other half of the class got 225 instead of 395. So, just like last time, I'm gonna draw both of these numbers up there, and we'll just do them sorted together. So we're going to do 395 and 225. Okay, the formula is going to be the same for both of you no matter what. Your formula for the first resonant frequency is, so 2n minus 1 times 340 over 4L. Here's the thing about your first resonant frequency. This n is going to be a 1. 2 times 1, 2. Minus 1 is 1. So basically we can just ignore all of it. That effectively means that your first resonant frequency is equals 340 over 4L. Your second resonant frequency equals 2 times 2 minus 1 times 340 over 4L. Okay, here's what I saw a lot of. People would take this number and they would put it in for L. What's wrong with that? Well, what's wrong with that is these are frequencies. This is hertz. This is hertz. Was that in the question? Yeah, of course it was in the question. The length of a tube with one enclosed that can amplify a 395 hertz tone. So it's definitely labeled as a frequency. So a length, like frequency, isn't a length. So you can't do that. That's not going to get you the right answer. No, the question is telling you that 395 hertz is the first resonant frequency, and it is the second resonant frequency. For the other half of the class, it's telling you 225 is the first resonant frequency, and it is the second resonant frequency. So what do? Well, basically, you cross off where your first resonant frequency and second resonant frequency are, and you add in what it's telling you the first and second resonant frequency is, or are. I'm not sure if I'm pluralizing anymore. Whatever, it doesn't matter. So let's move this down to give ourselves some we're going to move it down. $395 equals 2 times 2 minus 1 times 340 over 4L. Okay, so 395 equals 340 over 4L. Now I think that we have it in this form. You all know what to do. You're going to multiply 4L on both sides. So 4L over here, boom, they're going to cross out, and then you're going to have 4L times 395. We can simplify 4L times 395 by just multiplying 395 by 4, which is 1580. So we're going to say 1580L equals 340. Now all we got to do is get rid of the 1580. So L equals 340 divided by 1580, which means L is 0.215 meters. There's your answer. For the second resonant frequency, let's simplify this portion first. 2 times 2 is 4, minus 1 is 3. So we've got 395 equals 3 times 340 over 4L. You can multiply 340 by 3 to basically get 1020. So we're going to say 395 equals 1020 over 4L. Multiply both sides by 4L, which gives you 1580L equals 1020. Then you're going to divide both sides by 1580, which equals 1020 divided by 1580 is 0.646. And there's the answer to the second part. Okay, let's go back and do 225 hertz. Whoop. Okay, so 225 equals our first resonant frequency, which 340 over 4L. If you are watching this, you just clicked in and you're like, hey, there should be something in front of that. It's 2n minus 1. That's true. Go back and watch the very beginning of this round of answers, and I'll show you how and why I got rid of it for this particular question. For the second part, we're not going to get rid of it. 225 equals 2 times 2 minus 1 multiplied by 340 over 4L. All right. Up here on the first one, what we're going to do is we're going to multiply 4L by both sides. That's going to get rid of it over here, and you're going to have 4L times 225. We can simplify that by multiplying 225 by 4, which gives us 900. So 900L equals 340. And now it's pretty simple from here. All we have to do is divide by 900, divide by 900, and you've got L equals 0.378. There's the answer to your first part of the question. The next one, the first thing we're going to do is simplify this little bit right here. 2 times 2 is 4, minus 1 is 3. So we can rewrite this as 225 equals 3 times 340 over 4L. We can then multiply 340 by 3 because, 3 can be rewritten as 3 over 1 essentially, and then you can multiply the fractions. So 340 times 3 is 1020. So we're going to rewrite this as 225 equals 1020 over 4L. Same thing as above. multiply both sides by 4L, which gives us 900 equals 900L equals 1020. We're going to divide both sides by 900 to get L by itself. And you've got 1020 divided by 900, which equals L equals 1.13 meters. Both these are meters. There we go. That's question number 4. Okay, let's get rid of this and we'll take a look at question number 5. Almost everybody got question 5 correct. So we're just going to go through that really quickly. It's pretty simple. Draw the output of an 80 hertz tone, the first 8 harmonics, through the first 4 resonant frequencies of a tube. Draw the output of a 160 hertz tone through the first 3 resonant frequencies of a tube. The length of the tubes in both cases are exactly the same, 0.53125. So we're going to do the answers to both of these at the same time. All right. One is 80 hertz, one is 160. One's 4 resonant frequencies, one's 3. Okay. 0.53125. All right. So here we're going to do 80 hertz. Here we're going to do 160. In both cases, the length equals 0.53125, right? 0.53125. Yeah. Okay. What are the first 8 harmonics of 80? Well, it's 80, 160, 240, 320, 400, 480, 560, 1, 2, 3, 4, 5, 6, 7, and then 8 is going to be 640. 160 hertz, you're going to start at 160, then 320, 480, 640, 800. That's not an 8. 960, 6, 1120, and 1280. You're going to play these through the first either 3 or 4 resonant frequencies. Let's see, 80 is 4, 160 is 3. What we need to do is we need to figure out what are the first 3 and 4 resonant frequencies of a tube with a length of 0.53125. So we just slap that into the same equation that we've been using in exam 1 and also that we just used in the previous question, which is 340 over 4 times 0.53125, which equals 340, so 4 times 0.53125 is 2.125. 340 divided by 2.125 is 160. Crazy how that works out, right? Okay, 160 hertz. That's your first resonant frequency. Your second resonant frequency is going to be 2n minus 1. We're going to multiply that for each one of these, right? So first one is 1. 2 times 1 is 2, minus 1 is 1. So that's why it's just 160. The next resonant frequency is going to be 2 times 2, which is 4, minus 1. That's 3. So 160 times 3 is 480. That's resonant frequency 2. The third resonant frequency, 2 times 3 minus 1. 2 times 3 is 6. Minus 1 is 5. 160 times 5 is 800. And the fourth one is 2 times 4 minus 1. 2 times 4 is 8. Minus 1 is 7. So it's 160 times 7, which is 1120. That is resonant frequency 4. Why did I write 2 twice? Okay. So there's our resonant frequencies, 160, 480, 800, and 1120. Hey, those look familiar. Those are exactly what you calculated for some of your frequencies. It's like I did it on purpose or something. So over here, your graph is going to look like, oh, I have not given myself enough space. Maybe. We're going to have 80, which is not, it's not accentuated at all. It's dampened. Then 160. There's 160. Our next one. Let's see. To draw this out, I'm going to put also like the nodes in too, which would be the middle point between 160 and 480. So right there. And then here's 480. There's 640. There's 800. So we're going to kind of draw it like this. There we go. So, there we go. There's our filter. It's provided by the tube. And then we're just going to plop in the frequencies from the 80 hertz. So 80 will be like here. 320 is right here, so that's not getting accentuated at all. 240 is right there. 400 is there. 480 is there. It's accentuated quite a bit. 560 right there. 640, nothing. 560 is right here. And then 640. Oh, did I get off? I got off. Sorry about that. Maybe I should write in what these are. Here's 0. This is 160. Looks like 100. 160. Then we've got 480. Then we've got 800. Yep, good. 160, 480, 800. And then we need another one over here, 1120, which I didn't calculate. So 800, 960 is going to be here, and 1120 is going to be right there. Okay. All right, so we're focusing on 80 hertz right now. We've done 80. It's right here. It's about halfway up. 240. Let me write in 320, 640, 960, 1120, 1280. All right. So 240 right here. 320 is nothing. 400 is about halfway. 480 is all the way. 560 is about halfway, and 640 is nothing. So if you got the 80 hertz question, your graph is gonna stop here. Like, that's it. You don't have the rest of this going on. If you got the 160 hertz question, your graph is not going to include all the little guys. It will include that one. So 160 is there, 320 is not, 480 is there, 640 is not, 800 is there, 960 is not, 1120 is there, 1280 is not. That's what your graph is going to look like. So that's question 5. Pretty easy. Like I said, almost everybody got it right. So, good job. That was exam 2. Really good job. The highest score was only 3 points off of the possible total. So everybody's going to get 3 points back on that one. To put that in perspective, your exam 2, the highest score was 10 points off the total. Everybody's going to get 10 points back on that one. But it's not just one person that did better on this exam. It was everybody that did a lot better on this exam. So it seems like your studying is paying off really well. Way higher scores on both parts of the exam, but definitely on the hand calculation part. Excellent job. So exam 3, there aren't as many hand calculations. We're just kind of getting out of that portion. So there still are some. But there's less to study, and you're doing a lot better. So hopefully you do just, blow it out of the water. You'll do really well. And then on the cumulative final, all these questions will be back, but you have a lot of experience doing them. So I think you'll be just fine. Okay, I will see you in another video.